Thank you for bringing your lunch and watching me talk about data science and the Internet of Things. It seems like two completely disconnected things put together in one sentence. And I'm going to try and motivate why people should learn data science. Doesn't matter whether they're doing web development or interested in the Internet of Things or something else. If you're in the technical area, having an understanding of some basics in data science is important. Currently, it's for the specialists, but just like web development, everybody's going to be doing it soon, and this is more of a place where people are interested in staying on the cutting edge, learning new things, so this seems like a good place to talk about this. So I'm going to take a couple of minutes to talk about LearnDataScience. That's if you type that in and click on it, and it'll take you to a GitHub repo. The work on that was funded by Pivotal Inc., the parent company, about a couple of years ago. And it's a bunch of IPython notebooks that are actually tutorial content that can take you from absolutely not knowing anything about data science to the final thing, which is being able to analyze an Android accelerometer data set. And that's the one I'm going to talk about. I'm just going to jump straight in. I'm going to give you a brief introduction first to IPython Notebook, then to the lessons and how to go through them quickly. And I'm always available if you want any help, and I'm hopefully going to be writing some more of that in the future. So this presentation is a little hastily put together because I'm filling in for a speaker who didn't turn up. And so some of these things are blank and say something goes here and something else goes here, because this is a presentation that I'm going to give in a couple of weeks at the Internet of Things conference. So some of these things are not filled in. About me, that's not filled in. About LearnDataScience. But quickly, what will we learn here? The biggest thing that I'd like you to take from here is that it's important to learn data science. The content of this talk is just a brief introduction to give you a flavor of what you will get if you do that. Android phone data, obviously important for the kind of applications we build here, but in general. There's an article that I saw yesterday, how to use your Android phone as a cosmic ray detector. So that's interesting. Then I'll give you some sources of continuing to study if that's what you're interested in. And we'll talk a little bit about why machine learning. So data science, and I'm going to quickly draw a couple of Venn diagrams on the screen. Data science is many different things. Different people call it different things. Often it's confused with big data. Often it's confused with statistics. So here's my interpretation of what you need to learn to be a data scientist. And most of you have most of this. So one is, of course, data. The other is some math or stats. And the third thing is some scripting language. And typically, those are R or Python. And R is a little less approachable than Python. Most of you, if you've done any web development, you've probably done some Python, so it's not. But R is a whole other language, and I'd recommend, if you haven't learned it yet, you start with Python as an introduction to data science. And the math part is usually what holds us up. So my mission is to try and make the math part of it as less intimidating as possible. How many people have seen the Newsroom TV show? Newsroom on CNN? I'm sorry, HBO. So Will McAvoy, who's one of the characters, wants to make people more polite in their discourse. And so his statement is, I'm on a mission to civilize. And so I couldn't put that succinctly, but I'm on a mission to make math a lot more approachable so that developers are not intimidated by math, even if you've never really taken math before. So the next question he was asked was, how's it going so far? And the answer is, progress is slow, but I'm in it for the long haul. So it's one thing at a time, one talk at a time. And so we're going to start with the Internet of Things, but more importantly, phones, because for all those Internets of things that people talk about, we've had this phone thing for quite a while, and all kinds of interesting applications are being built with it. And there's a lot of data coming off it, and people are focusing on how to make the interactions with the user more interesting and how to make the data more presentable. But the amount of data that's going to come online is going to be many orders of magnitude than what you see right now. And if you have these kind of tools, you'll be able to do it better. So the important thing is not just the devices, but you want to understand the data and the metadata and what to do with it. And most importantly, you want to make it actionable, not just. And so here's some examples. This is from a book called Make Sensors. This is an O'Reilly Maker Media book. These are the kind of values that you can get from the different kinds of sensors that you might see when you try to go and measure things. And these are digital resistance, analog resistance might be for some settings of a thermostat, a pulse length maybe when you're trying to measure how long something's happening, and so forth. And these are the type of sensors you might encounter, and you will at some point. And the important thing is to know where the data comes from, when it was recorded. And so finally, this is basically what you're going to be dealing with. You're going to be dealing with a vector or a tuple of a timestamp, a location, a user ID, and then a bunch of data. And then you want to take a ton of this and try to figure out, make inferences from the source. And so if it's a phone, the data set I'm going to talk about is something that was done at a university in Italy. They had a Samsung phone attached to people as they went about their day. And then they took accelerometer readings and gyroscope readings. And then they tried to figure out one of whether the person was doing one of 6 things. Walking on a level ground, sitting, lying down, standing, walking up, or walking down. And by a set of these, by classifying these readings into various buckets, you're able to do that. And so I'm going to go straight to that particular IPython notebook that talks about how to do it after taking a quick step through IPython. So first, a few things about data science. And there's a lot of different algorithms you'll see that are complicated names and all kinds of things. But what I'm trying to do is to simplify it and put it in 2 categories. So you're either finding trends and trying to predict things, or you're trying to find classifications. So even by being programmers, you probably have heard of the term k-means clustering, because that comes up a lot. And when you're trying to build recommendation systems or you're trying to classify users into different categories, you try to cluster attributes into things that look similar, and then when the next user comes along, you want to see which one of these it goes in. Or you're making some readings and you want to see a trend. How is growth going to go? Is it going to be linear, or is it going to be exponential, or whatever? There's a link there that hopefully these slides go somewhere, but this was a very interesting thing someone did. This was a radio-controlled car. This guy put an Android phone on top of it, and he did some live neural network calculations and made it follow a line on the ground. And he did a very complicated line, and it was live sending data to his laptop where the neural network was computing things and sending it back, and he was able to follow this. So you can do all kinds of hacky things if you know the stuff that's behind. So what do you need? And that's what we're going to go through. So mainly 2 things. Regression is a term used, it's an old holdover from psychology, I think, when people were trying to make some observations. But think of regression as your best fit line. In your physics lab in high school, you make a bunch of observations and you had to jiggle the ruler till you got the best fit line through. That's regression in general. Classification is when you look for similar attributes and you cluster, and then you look and see where the next one goes. These are the 2 main things you're doing in data science ever. So I'm going to quickly switch to IPython Notebook for a second, and then I'm going to go into the LearnDataScience part. Right? So how many people know about IPython? Forget the notebook. IPython? IPython? Just Python? Plain Python? Okay. IPython is a more powerful Python command line. So think of the difference between Bash and Z shell. So Z shell for Python, if you will, does a lot of amazing things on the command line. And IPython Notebook is just yet another thing on top. How many people have heard Mathematica? Mathematica? The great thing about Mathematica was that it had these web documents, or initially it wasn't even web, but what they called computable documents. You would write a bunch of things, text, and you'd write some code. And then you would hit Shift-Enter, and it would actually compute the thing and put the results. And so IPython Notebook was actually motivated by creating an open source Mathematica. Mathematica is closed source, has always been. It's awesome, but it's generally expensive for the average person. And so IPython Notebook was motivated by that. If you want to see it, it's ipython.org/notebook, or you can take a look at IPython Notebook, or just Google IPython Notebook. So I can take you to a quick step through what you can do. You can embed URLs, and they can render. You can put chunks of Wikipedia text. But remember, it's all in the browser. It's an interactive environment. It's not something you build applications with. Think of it as a web console for Python on steroids. And since Python has so many data science libraries, it has become a great place for data science, hacking, and interactive programming. So that's really what I'm going to focus on after I show you a quick step through IPython. There is also something called Notebook Viewer, NB Viewer. And this is something that runs on Heroku. You upload your notebooks, and then it will create a static version of them. They're not editable. And you might see things like Julia and Ruby and wonder what that has got to do with Python. But it has the ability to call out to other interpreters, do some work, and put the results back in, marshalling all the methods and the parameters back and forth, and providing an ability to just display them back in Python Notebook. If you're interested in following up some of this, this is a great book. It expects a little bit of understanding about probability, but if you really want to build useful applications, that's a great one. Mining the social web is the next version of the original one. This time, it's a lot of IPython notebooks in it. And of course, signal processing. You can do XKCD type plots if you want. And then there's some interactive visualizations. It just gets deeper and deeper. It's a very powerful environment. And NumPy is doing numerical calculations, and SciPy algorithms. And we'll be implicitly using some of these. So I'm going to step next into, before that, let's go look at so that's a little GitHub Pages thing, and notice this was done by this. And Alpine Data Labs, they've got a project going on downstairs, and it was actually paid for by Pivotal, but some project management was done by Alpine Data Labs. And it's all mainly written by me. These, in my opinion, is the first 4 things. If you're a developer and you just want to start exploring, these are the things you should have in your toolkit. They're very powerful. And I'm going to focus on random forests because they're really powerful. We use 2 data sets. One of them is from something called, that's a typo, it actually should be Lending Club. And the Lending Club is a peer-to-peer lending site, and they make a lot of data available on who gets a loan at what rate based on what your FICO score was. It's anonymized, but it's a great way to try and figure out if I'm looking for a loan at this interest rate and this is my FICO score, what's the chance of me getting it? Or let me create a model. So that's what I use in the initial cases. And then the other one is this human activity recognition database. And I have the link in there. And basically, there's about 10,000 data sets. This is the data points. This is an interesting thing. You have 561 attributes. So how do you deal with a data set that is 560 plus dimensions? And that's where a tool like Random Forest comes in. It's very good for taking large number of dimensions and reducing it down to the top 10 or 15 or 20. I mean, it's amazing what power you can get of that. It's computationally intensive, but this particular thing ran on my laptop. for maybe 10 minutes and then came up with something. So all of this stuff is now packaged into these notebooks, and as I'm going to show you, if you just want to play with it, all you have to do is to go there and run this, click on something that says cell, run all, it'll run everything, and then it'll have all the cached all the variables it needs. You can go to any cell and you hit shift enter, it'll compute, you can play with it, change the parameters, and you can pull in your old data if you want. So once you go into Learn Data Science, you will see this. This is, all of these are, each one of these is a notebook. And I'd strongly recommend you go to the before you begin one. It'll tell you everything you need to do, what you need to set up. There are a couple of Python distributions that come with IPython Notebook and all the scientific libraries built in. I would recommend those, not the ones from python.org, because you really have to do a lot of work to get the right combination of things in place. It tells you right down to the last detail what you're supposed to do. So if you're going to do that, I would recommend going to take a look at this. So I'm going to quickly give you a flavor. Notice that we're looking at linear regression, logistic regression, random forests, and clustering. And each one of these has an overview, a data exploration, and then an analysis. And that's typically the kind of steps you follow if you're doing a data science exploration of a data set. And actually, I kind of massively reused stuff. I was taking a class on Coursera on R and data science. And so this is really a sufficiently complicated problem to be a intermediate level university problem, at the same time a real world problem. So it's not a toy problem by any means. And you can, if you spend some time with it, you can go and actually do some useful work. If you feel like you need to go slowly and go through everything, this is about 4 weekends of work. If you take one algorithm per weekend, work on it, within 4 weeks you'll have a really good toolkit to do this kind of stuff. So I'm going to start off by giving you a flavor of how this thing goes. So in all of these things, I've talked first about why do you want to do this? And then what's an easy way to think about it? So linear regression is lab experiment. You make all these things, all these observations, and now you've got to draw a line. And when you do have a line, then you measure the slope, and then you measure the y-intercept, and then now you've got a model. So what you're saying is that there's a pattern here, and the line represents the pattern. Now, I've artificially created these dots, but your observations may not be linear. They may look like a parabola, in which case you use something else. So you start off with linear regression, and there's a little bit of math here, not much. And if you ever did a lab experiment in school or anywhere else, then this shouldn't be too much of a problem to get started. My goal for the first one, and I think everybody here passes that, is that it should be understandable by a TechCrunch editor. So I think even the most non-technical person in this room has more technical information than a TechCrunch editor. So you should be able to understand that. You go here, we're actually going to look at some data. You do some data cleanup. That's real world data sciences. You spend, the joke is you spend 80% of your time cleaning up the data and 20% of the time complaining about how you have to clean up the data. And so there's some data cleanup stuff. It'll give you a flavor of what you end up doing. But with that, I'm going to go straight into the random forest stuff. So what do you do when you have a high number of variables? I talk a little bit about that. What is random forests? What is the meaning of this term? So first of all, we start with decision trees. You've likely heard of decision trees a lot more than you've probably heard of random forests. And this is a somewhat macabre example of who survived on the Titanic. And essentially, if you were in the more expensive berths and you were a woman or a child, you survived. If you were male, not a child, not in one of those, you died. And then, based on these attributes, you can split this data set into different sections and calculate the odds of someone who's in one or the other category may have survived. Now, we're not going to get into that, but if you read some of the stuff above, it may also apply to try to figure out who gets admitted to a university. And that's with a small number of variables. But if you use a decision tree in a real-world example, you don't get very good accuracy. So what a random forest is a bunch of decision trees, and they're all trying to make a model, and you take a statistical collection of these decision trees, and you run a lot of them, typically 500, 5,000, depending on how much compute power you have and how many variables you have and how badly they're spread out. Sometimes the difference between 500 and 5,000 is not much. So you want to run a large ensemble of decision trees, and a random forest is a technique to pull out the best possible answer from that. So that's a very simple summary of what a random forest is. And now, we'll take you straight to the code. So first, the data before that. So the actual data that comes from this experiment that I told you about is about 21 subjects. It's got about 7,000 rows, and as I said, 560 variables. But it's very, very, very messy. You could possibly not be able to do anything with this without some heavy machinery to understand it. Even the column names have things like method names followed by double parameters in the name of the variable. They're long names, and some are duplicate, and some are redundant pieces of information. And some have Fourier transforms of the time-varying data. So making sense of these and trying to understand it based on what you know is probably not going to be very productive. And you need some machinery to go through this and filter through this and bring it down. So first of all, I actually wanted to go through that pain to understand what the value of it is. So for my class, what I actually did was I went to the Android site and I looked at the accelerometer and gyroscope information. And I tried to imagine if somebody had a phone attached to them, and if they were sitting, then what would the accelerometer say, what would the gyroscope say, and then how would I differentiate between that and someone who was sleeping versus sleeping and walking up? What are the big differences? What looks similar? And then I narrowed all of these down after cleaning them up, and by the way, by hand, to some 36 variables. And here's an example of something I did by hand. So this is a graph that says, if this is the color, then this is the acceleration of your body, the magnitude of acceleration of your body when you're doing one or the other. And there's a ton of these variables. So you really have to find out a collection of these implies this kind of activity. A collection of these implies that kind of. It's really painful to do by hand, having done it. And so what this tells you is that when you're walking, generally you have some acceleration going on. When you're lying down or sitting or even standing, you're not accelerating. It's a static position. So that's all this picture is saying. And I actually went through looking at many different variables like this to tell which ones of them didn't separate out nicely and which ones of them separated out nicely. Luckily, you don't have to do that. But then I cleaned it all up, and I reduced it down to a bunch of variables. Again, you don't have to do that. I'll tell you what happens. So this was the data cleanup. And the next part is really the interesting part, which we'll get into now. So this is the analysis. So what we're trying to do now is to take this data set. So first of all, there's a methodology that when you're given a data set and you're creating a model, you hold out some variables that you're going to then use to test your model. You don't look at that because you really want your model to be effective at testing new things that come in. You don't use that data in your modeling. And so that's called a holdout set. And so we hold out some of these 21 people, the data for them, and you do analysis on the other. And so there's a little experiment segue on how this experiment is designed. And so we are going to take 4 and keep them aside, and you're going to look at 17 and use the first 12 as the actual training set. Then you validate these. So going straight into this, this is the code, right? We're going to pull the data in. There are different sets of data. We're going to import a library called random forests. We're going to learn and train and create a model. And then there is a measure of accuracy called out-of-band score. If you want to read more of that, there's some references. But what they're saying is that it looks like you've got a pretty good accuracy going. Now, feature importance is really important, and what this is going through even the 36 features and telling you these are the ones that are really contributing to the difference. And as far as data science is concerned, that's the first thing you want to do, is to figure out what the important features are, important variables, important dimensions, got different names, dimensionality reduction. So if you're collecting data from some sensor and you're getting tons of data, then what are the most important variables? Go ahead. There are different things. You mean this number? Oh, this is the actual value. So I'm sorry. This is how much it contributes to variance. So no. Suppose you had it's a relative contribution to variance. Variance. So in other words, yeah. So and it's sorted by that, and there's a value. And so these are the ones that contribute the most, and then you can resort this, right? And then what you're going to do is predict some accuracy, and then this is where it's visualized. Is now the 1, 2, 3, 4, 5 are actually the different activities, and it's called the confusion matrix because in reality it could be sitting and your model is predicting that you were standing. And so there's a confusion between the reality and the predicted thing. And the more off-diagonal things you have here, the worse your model is. It's telling you that your confidence in this prediction is not that great. Your confidence in this prediction is pretty good. And so the confusion matrix quickly tells you, and by the way, it's like a one-liner using these tools to actually take the results. But there's a lot of things that happen before you can build the confusion matrix. And the lessons go into it. And then we compute some other things. There are statistical, a lot of these come from pharmacology and when people do clinical tests and so forth. And so they compute a number of these things, accuracy, precision, recall. You also have when you're trying to find a document, so there's a whole other technology area where you're trying to find the best fit for a search term. They also have these terms. And what you're trying to do is to try to get as high a score as possible. And so 90% is not bad. You can do pretty well in guessing that 90% of the time. So here, we did it by literally me going through all of these. And I'm going to contrast it with if you didn't know anything about the variables, you had 500 variables and you just named them x0 through x500 and whatever. And the last one you kept as the activity, the person. And you just want to find out which ones of these are good for modeling. And so that's what I did in another one. And so let me go back to that. So down here are some worksheets that actually allow you to play with the code without messing your stuff up. And so in here, instead of data cleanup, what we're going to do is to just take this, name them x0 through whatever, and then I'm just going to do some reality checks to make sure I got all the data. And then I'm going to run this stuff all over again. I'm going to train it. I'm going to just look for some unique values to, again, reality check. And again, notice that this score is better marginally than the previous one. It was 0.97. This is here. And so I got a whole different set of variables here. When I actually translated that back into what I had, there was a strong overlap. And here's the confusion matrix again. Looks relatively similar to the previous one. So even though this came up with an automatic model, it didn't really improve the difference between, say, standing and walking or sitting and lying down. It's one of those two. I don't remember which one. But that came out to be pretty much the same. And these numbers were 0.89 in the previous one. You got 0.91. Now, the big difference is you don't have to do a lot of manual work in this. And in this case, you probably got a slightly better reading. That's not always guaranteed. But as a first pass, that's what you might want to do when you have a large data set, is to just throw it, understand what random forests are doing, understand some of these things, throw it. Most importantly, even if you don't do anything, don't build a model, it's useful for picking out the top 10 variables. So then all of that, and now I went back and looked at what the actual variables were. And so I should write them out vertically, but there's a lot of overlap between the ones that the system came out with and I did by manually wading through a lot of pictures. And then there are some new ones. So the real intersection is what you would have as the core variables that are important. And so that's a rapid, intense introduction to how to use random forests to model or rather make sense of data that comes out of your Android phone. You could use it for many different things. When I was a PM, I was looking at the backlog and looking at some of the, what if I could use random forests on the Pivotal Tracker to understand things. And that's possible. I think there are some insights you could get. So if you have a tool that can process massive amounts of variables, there's some very interesting things you can do. And if this is something that's interesting to you, please don't be intimidated by the math part of it. Start at the beginning, and there's also a Google mailing list where people have signed up and are answering questions. So, and please get in touch with me. Let me put my information back. Contact me on Twitter, and then I'll follow up with you whenever you want. I'm in and out here, so if you need to get in touch with me, there are people. Dan was there, he knows, and I think the organizers also know how to get in touch with me. Questions? Yes?
So for the IPython Notebook, it looks like you support, or it supports other interpreters.
It does support other interpreters, yes. You can most certainly do R with it. I've used R. Compile languages. So essentially what it does is it spawns out to some process, and it pipes std in and std out back, and it does some wrapping of that with a div to put it back into your thing. So if you're running compiled languages, so here's how it works. I'm quickly going to do this. Maybe I can draw it out here.
So with the Ruby interpreter, if you have some massive data set that you process it with Ruby and IPython, and then you run like another step, will it have to rerun the Ruby and reprocess the data set, or does it keep the Ruby process alive and the Python process alive?
Well, it won't. The only process that's actually kept alive as a part of IPython is the Python kernel.
So in particular, the Ruby thing that...
You will have to figure out when it calls the Ruby interpreter. Otherwise, it's per call. The interpreter goes.
Like, because if it's just in Python, it won't reprocess that big data set, right? Like it'll...
Well, I mean, it will save the results. And you can do the same thing with the Ruby results. The data set hopefully is on disk or somewhere.
The data set's on disk, but say you're loading a massive data set. Right, that takes 5
But
minutes.
you don't want to load it in the browser, right?
You need to load it into memory. How do you...
Well, okay.
So you're loading your CSV files.
Correct.
Right?
So that is in memory. So when you say massive memory, what do you mean?
Something that'll take up 4 gigs in memory.
Okay. So now, I would say that's what you want to load up in Python. I don't know how you would coordinate between the Ruby. You could, you know, there's a little bit more work you need to do.
So is IPython more for like exploring at a small level?
No, it's limited by the amount of memory you have. And also there is a parallel version of IPython that you can spin up a lot of parallel interpreters in the background. You can go really wide if you want. That's the Python side. When you integrate with another language, you have to do a little bit more work, right? So if it's not too much work, you might want to take a look at rewriting it in Python if that's possible. And then you get much tightly integrated with this exploration loop. If that's not possible, then you might want to figure out some messing, because it uses ZMQ in the background to communicate back and forth. So you might want to look at whether you can send messages and do some communication that way. So I'd encourage you to take a look at the internals a little bit. They've documented the protocol. If you can run your thing as a long-running process and then just keep sending it messages, maybe that's the way to go. So there are a number of ways. I mean, I can talk to you and later if you want. So anyway, anything else? You're all set? Okay, thank you very much.